All right, guys, I hope you enjoyed the 5-day break. Yeah.
Good afternoon, Colquitt High School. The Colquitt High School Lunch Show, Friday, March 6th. If you'd like to share your talent with others, please stop by and sign up before March 3rd. Why don't you do the very thing?
So, what we're doing today is continuing on with what we started with before the 5 snow days, and that's our rational functions. Now, today we're actually going to be solving rational equations. Now, the first few say by cross multiplication or cross multiplying. Now, technically we will be doing cross multiplying for these first few, but I don't really like the term cross multiplying because, again, later on, especially I've seen a lot of students who, well, during observations of college algebra and college classes, some students get this mixed up with just fractional multiplication. And there's another way to do this. Also, cross multiplying works well until we have 2 terms on one side and 1 term on the other. It doesn't work as well. So instead, we're going to be doing something that is essentially the exact same thing, but just looks a little bit different. And what we're going to do is multiply both sides by the least common denominator. Least common denominator. Essentially, we're going to multiply both sides of this, or multiply every rational expression, or every expression in this, by a certain expression to get the fractions to simplify. Because if we look at the 9 over 4x plus 5, if we multiply this fraction by 4x plus 5, what's going to happen? It's going to cancel out with the denominator. Over here, if I multiply the one on the left by x plus 1, these will cancel, yes? But if we do it on one side, we have to do it on the other. So we're going to have to multiply both sides by 4x plus 5 and multiply both sides by x plus 1. We need to do both. Because over here, the x plus 1 and x plus 1 would cancel. Here, 4x plus 5 and 4x plus 5 would cancel. Now what that leaves us with is 3 times 4x plus 5 is equal to 9 times x plus 1. Any questions on this so far? Now at this point here, we just need to solve. So the first thing we can do is distribute the 3. 3 times 4x is 12x. 3 times positive 5 is going to be plus 15. Is equal to, here we can distribute the 9. 9 times x is 9x. And 9 times 1 is going to be plus 9. Now we don't have any like terms on either side to combine, so we can go on and start solving for x. So the next thing we can do is 9 or 9x? 9x. Either would work, because we could subtract 9 first, or we can subtract the 9x first. We just need to pick one to do. So here, 9x subtracted away from 12x is going to be 3x plus 15 is equal to 9. Now we will subtract 15 from both sides, telling us that 3x is equal to negative 6. And last but not least, we would divide by 3, telling us x is negative 2. And that's it. That's all we would need to do for this here. Now, one thing we can do is we can check to make sure that this is the correct answer. Check to make sure that they work. And all that implies, or all that entails, is just taking it and plugging it back in. And seeing if it is equal to 9 over, well, and seeing if these are indeed equal. Because if they are, then that is the correct answer. Now we can do them by hand or we can do them in the calculator. Either way works. Because for our first one, we have 3 over negative 2 plus 1. 3 over negative 2 plus 1 is negative 3. Our other fraction, 9 over 4 times negative 2 plus 5. 9 over 4 times negative 2 plus 5 is negative 3. So that does show us when we plug it in, both sides are indeed negative 3. They are the same, so it works. The value is not really as important as the fact that both sides are the same value. Questions on this here? Let's look at another one of these. Now, when we do these here, it's really somewhat or is important to make sure to factor the denominator so we don't have anything repeated or using things more times than we absolutely have to. But when we look at this here, x plus 2 is as simplified as it gets. There's no greatest common factor between x and 2, and the degree is 1, so that's as simplified. 3x plus 2, no greatest common factor, no way we can simplify it, so we're good there. So what's one thing we would multiply both sides by? Yeah, x plus 2. Because on the left side, the x plus 2 and x plus 2 would cancel. 3x plus 2 and x plus 2 won't cancel because they're not the same. What else do we need? 3x plus 2. Because these two would cancel here, and we'd have it on the other side as well. So what that would leave us with is 2 times 3x plus 2 is equal to 10 times x plus 2. Now at this point here, we would distribute. 2 times 3x is 6x. 2 times 2 is 4. We do the same thing on the other side. 10 times x is 10x. 10 times 2 is plus 20. Now what can we do next? Yeah, we can subtract 10x. Yeah, for this next one here, it's really picking out which one we want to do, because we could subtract 10x from both sides. We could have subtracted 20 from both sides. We could have subtracted 6x from both sides or subtract 4. We just need to pick one to do. So we subtract 10x from both sides, which will tell us that negative 4x plus 4 is equal to 20. Now the next one has to be subtracting 4 from both sides, telling us that negative 4x is equal to 16. And last but not least, we would divide by negative 4, telling us that x is equal to negative 4. And that's it. And we can plug it back in and see that, yes, negative 4 is the correct answer. It would make both sides be the exact same fraction, the exact same value. And that's it. Questions on any of this here? And again, especially if the numbers look weird or they don't seem like they worked out the way that you thought they would, plug them back in, check them. Now, there's one thing I will look at this here if we look back up. What would make x plus 2 be 0? Negative 2, yes, because negative 2 plus 2 is 0. That one's easy to see. Now, 3x plus 2 would be negative 2/3. These are our restrictions. We talked about these when we did addition, subtraction, and multiplication, division. It's been a while, but these would be the restrictions. Now, listing them here is not necessary. It's not part of the answer, but especially when we start looking at tomorrow's, it's going to be helpful. Because if negative 2 or negative 2/3 came up as one of our solutions, we know it doesn't work. Because those values would make the denominator be 0. We can't have those as part of our answer. And that's helpful in that we get all the way down here. Okay, we got one of those as a solution. We can go on and mark it out. We know it doesn't work. That way we're not having to go back and check every single one to make sure that they do work. Questions on this here? How do we feel about these here? Feel good with these? In that case, we'll skip over those and look at this one here. Now this one here is a little bit different because this is the first one that we have, that's had a variable in the numerator. Because all the rest that we've had, the 2 that we've done so far, have had numbers, which are nice. Now, it's not going to change what we do. The overall process isn't going to change. Because one of the things we know what we'll multiply both sides by is 2x plus 5. Because here the 2x plus 5 and 2x plus 5 will cancel out. Now 2x plus 5 doesn't reduce. 2 and 5 don't have a greatest common factor. There's no way to factor it. So that's fine there. We know we'll also need to multiply both sides by 11x plus 8 because these two will cancel out. Now what that does leave us with, well, on the left side we have 1 times 11x plus 8. That's just going to be what? 11x plus 8. Multiplying by 1, I think, especially in kindergarten or younger grades, was the nice one to do right after 0. 0, I think, is the one we always like multiplying by because everything turned out to be 0. Now, on the other side, we have x times 2x plus 5. Yes, we do need to distribute, which would give us 2x squared plus 5x. Over here we have 11x plus 8. Now with this here, because we have an x squared, we need to get it equal to 0. We need to move everything to the same side. The only way that we wouldn't need to necessarily do that is if the x squared terms would cancel out. There's an x squared on the other side that would subtract and make it 0, which we don't have, or if the middle term became 0. Unfortunately, in neither case, we have that. Because if we go on and subtract 11x from both sides, the left-hand side will be 8 is equal to 2x squared. Well, 5x minus 11x is negative 6x. So that just means we can't use the square root method. That x squared by itself takes square root of both sides. It also means that we're definitely going to need to get this equal to 0. Any questions on how we got to 2x squared minus 6x minus 8 is equal to 0? Will this factor? It will, yes. But it's not the easiest one to see. Is there a greatest common factor, though? 2. What we can do, if it's just a number, we can divide it out. If it's a variable, we can factor it out. We can't divide it out. We need to factor it out. Because anytime you divide a variable out of the entire equation, you're removing a solution. Mainly, you're removing most solutions of 0, the 0 solutions. Well, the solutions that are 0 out of it. But dividing by 2 is going to change everything except for the solution points. It'll change everything else about the function except the solutions. And if we do this, well, 0 divided by 2 is 0. 2x squared divided by 2 is x squared. Negative 6x divided by 2 is negative 3x. And negative 8 divided by 2 is 4. I have a feeling it'll be a little bit easier to solve x squared minus 3x minus 4 than it is to solve 2x squared minus 6x minus 8. A little bit easier to work with. So we do our 2 sets of parentheses with 3 spaces. Since the 4 is negative, our signs are opposite. Factors of x squared are x and x. Factors of 4 are 1 and 4 or 2 and 2. We're going to want 1 and 4, and the 4 will need to be negative. Now we have 2 things multiplied together to equal 0, so one of them must be 0. So for the first one here, we can subtract 1 from both sides, telling us x is negative 1. Here we can add 4 to both sides, telling us x is equal to 4. And that's it. Now we could check it to make sure this works. Saying 1 over 2 times negative 1 plus 5 is equal to negative 1 over 11 times negative 1 plus 8. And check to make sure that this works. Now, I should have mentioned this to the other classes, but I will definitely be mentioning it tomorrow. If the test says to check your solutions, you need to check them. I do assign points for checking them. And really, all you need to do to check the solution is, one, write the thing out like this. Then you can grab the calculator. You don't have to do it by hand. We can type in 1 over 2 times negative 1 plus 5. Okay, that's 1/3. 1/3. Then we can type the other one in. Negative 1 over 11 times negative 1 plus 8 is also 1/3. Okay, it works. We checked it. We made sure it worked. Now we can do the same thing with 4. You can say 1 over 2 times 4 plus 5 is equal to 4 over 11 times 4 plus 8. Grab the calculator again. 1 over 2 times 4 plus 5 is 1/13. 4 over 11 times 4 plus 8. It's also 1/13. Okay, they check. They work out. So that's it. That's all we'd have to do with checking the solution. We just have to plug it back in, make sure that they work. And again, if this was on the test and it asked you to check your answers, you have 2 answers. That's 1, 2 easy points. Plug it back in and check. It'll also let you know if you got the correct answers or got the wrong answers, because it's an easy way to see if it does work or if the solution doesn't work. Questions on this here? Question on anything we've done so far? We're ready for the next one. Now this one here is a little bit different because here we have 3 fractions, when on the other ones we only had 2. But the process that we're going to do to solve this doesn't change. It's not going to change at all. Because like we were working with the last one, we were really finding the least common denominator. What we were multiplying both sides by was the least common denominator. An expression, when multiplied by every term, will make all the denominators simplify out. What's one thing we know we'll need to multiply all 3 fractions by? X. Because all 3 will need to be multiplied by x, because we do have an x in the denominator. What else will we need? A 4, because the middle one has a 4. And we could go through and cross them out, because we can say that this x will cancel out with this 4 will cancel out with this 4, and this x will cancel out with that x. Yes? So let's see what that leaves us with. The first one's 5 times 4, which is 20. Plus, here we have 7 times x, which is 7x. And lastly, we have negative 9 times 4, which is negative 36. We need to get x by itself, so the first thing we can do is subtract 20 from both sides. And if we subtract 20 from both sides, we get that 7x is equal to negative 56. And lastly, we would need to do is divide both sides by 7, telling us x is negative 8. Questions on this here? Why would we only need x and not x squared? Because x does show up twice, yes? Yes, because there's only one x in each of the denominators, there's not two. Y'all see that there? And going above the least common denominator will still get you to the right answers. It will add a few, and it'll make it a little bit harder. Okay? So I'm going to show you this here, because if I had said x squared, because this is sometimes easy to do, we'll add an extra one. One of them will cancel out here, leaving us with 1x, 2 and 1. Now our equation is 20x plus 7x squared is equal to negative 36x. With just the x, it's not made it a whole lot harder, but it is a step harder. Because here, we would need to add 36x to both sides, which will tell us that we have 7x squared plus 56x is equal to 0. Well, there is a 7x in common in both terms, which gives us 7 times x plus 8. Since we do have two things multiplied together to equal 0, one of them must be 0. So one of them, x is 0. The other, x is, well, we did have that in the first one, yes? Now the 0 doesn't work. Let's look back at our starting one. I'll erase. Go back up. Erase this here. What would make this denominator or this denominator be 0? What would make x be 0? 0. So one of our restrictions is that x cannot be. So when we added that extra x, we added one of the restrictions back into it. So any one we go above the least common denominator, any extra expression we add in will give us an extra solution. That's an extraneous solution that doesn't work. So going above that makes the problem, as we can see here, a little bit more challenging to work, giving us extra solutions that don't work in the end. So making sure to find the least common denominator is very important. Are you ready for the next one? Now, one way that we can go about making sure that we don't go above the least common denominator is pick it one fraction at a time. So if we look at the middle one, x 8 over x minus 5, what would I need to multiply that by to get the denominator to simplify? X minus 5. If we do it to 1, we've got to do it to all of them, because these here would cancel out. Now we skipped over the 1 because, well, 1 does not have a denominator other than 1, so we don't have to do anything to it. Are there any other denominators that we have? The x. So we'll also need to multiply everything by x. Because this x and this x will cancel. And unfortunately, the x minus 5 doesn't cancel out with that x. Let's see what that leaves us with. So the first one's going to be 1 times x minus 5, which we can just leave as x times x minus 5, minus 8 times x is equal to 3 times x minus 5. Now the first one we can distribute x times x is x squared. X times negative 5 is negative 5x. And negative 8 times x is negative 8x. Here we can distribute the 3. 3 times x is 3x. 3 times negative 5 is negative 15. We can combine like terms. Negative 5x minus 8x is negative 13x. At this point here, we do have an x squared term, so we'll need to get this equal to 0. So we can subtract 3x from both sides, which will tell us that we have x squared minus 16x is equal to negative 15. At this point here, we can add 15 to both sides, which tells us that we have x squared minus 16x plus 15 is equal to 0. Now at this point here, we could graph it, we can factor it, we can use the quadratic formula. Any of these will probably work. We can go on and factor. Since there's no greatest common factor to factor out, we don't have to worry about it. So we can do our 2 sets of parentheses with 3 spaces. Since the 15 is positive, the signs are the same, and they match the sign of the middle term, which is negative. Factors of x squared are x and x. And the factors of 15 that we want are 15 and 1. And since we have two things multiplied together that equal 0, one of them must be 0. So for the first one, we can add 15 to both sides. Telling us x is 15. For the other one, we can add 1 to both sides, telling us x is 1. That's it. Any questions on any of this here? That's really it. So I do have other examples listed here, but I'm going to let you all have the rest of the time to work on the assignment. And if you do have additional questions, please ask.